terms of time. And it represents a collaboration between Olga Ast, who sits next to me, is one of our panelists, and Hallie Cohen and Adam Ludwig, all working on this together. So Olga, I wanted you to first say a couple of words about the show. A lot of times people come into Philoctetes and we put up these shows and they don't realize that the shows are coeval with the panels, and they work synchronistically with the panels and sort of elaborate in visual terms some of the themes that we deal with. So Olga, would you want to say a few words about the show and what your thoughts were on it?
Okay. I started to work on visual metaphors and particularly visual metaphor of time some time ago, and outside you could see the big poster with different traditional visual metaphors of time. It's with well-known artists mostly. And here here you can see contemporary artists who present their different visions of time. And from my point of view, it's very important to come together and discuss how differently we perceive, understand, and see time. That will be it.
Yes, and this show encompasses the work of John Boone.
Yes, John Boone. This is Linda Stillman. This is Elliot Kaufman. There, Catherine Davis. Catherine Davis is actually, it's their last works. She is a science student in California, and it's very interesting, her theory, and it's just illustrations of her theory. And Edwards, Johnson Edwards.
And Ellen.
Yes.
Ellen Weiner, where is she? Hi.
Hi.
She came aboard and we're so happy to have her too. So, a couple more announcements before we continue. Poetry continues on December 8th with Madmen, Exiles, and Savage Detectives, Latin American poetry from Arenas, and I'm not pronouncing that correctly, to Bolano. And so that's with Jaime Manrique. He's a good friend of mine, and I'm really looking forward to that one. I urge all of you to come. On December 17th, we'll be presenting a roundtable called Love and Pleasure in the Age of Electricity. This roundtable, to get the title for this roundtable has taken weeks of work. Because it deals with the invention of the vibrator. But it's tied to Sarah. So we both wanted to be explicit, implicit, and extrinsic at the same time, and it was causing problems. But it's tied to the Lincoln Center production of In the Next Room, the Sarah Rule play. Sarah Rule was going to be joining us, but she cannot for certain reasons related to her health. But we are having the roundtable in any case, and that should be a rather interesting roundtable. And we conclude our season with Aging and Creativity on December 19th. Now, you may have read on our site that we're proud to be the recipient of a number of grants, the Templeton Foundation, from the Leon Levy Foundation. We're going to be getting grants from NYSCA, in New York State Council on the Arts and Poetry, grants in music, and we received a very generous grant from the Department of Cultural Affairs of the City of New York, and from Bloomberg LP. The grants, though, represent a fraction of what it costs to run the Philoctetes Center, so it is very important, we feel, and I hope you do too, that we stay in existence. In order to stay in existence, we need your help. And we need the help of patrons and individual donors who can give from small amounts of money, and large amounts of money have come from very generous people, but that's what we need. We need your help to stay alive. And so with that, I will now introduce Mark Norell. Mark Norell is chairman and curator in charge of fossil, amphibians, reptiles, and birds at the American Museum of Natural History, and professor of paleontology at the museum's Richard Gilder Graduate School. Dr. Norell worked in several areas of specimen-based and theoretical research. He works on the description and relationships of how do we pronounce it?
What is it? Give it a try.
Yes. Cophorosaurs.
Oh.
You don't know what they are either.
I don't know what they are either.
Okay. That's just a pass by. And studies, we'll come back to them.
All right.
And studies elements of the Asian Mesozoic fauna. He analyzes important new feathered dinosaurs from Liaoning, China, and develops theoretical methods for better understanding of phylogenetic relationships and patterns in the fossil record. Norell has an interest in Asian art and history, sits on the board of the Rubin Museum of Art, and is curator of the AMNH exhibition, The Silk Road, Ancient Pathway to the Modern World, which is a wonderful exhibition. Mark Norell will moderate this afternoon's panel and introduce our other distinguished guests.
Great. My name is Mark. I've been on a couple other roundtables here and really enjoyed it. And, you know, I was talking with Francis and Ed a couple years ago, and we decided that, or we didn't decide, we were just sort of in talking, that one of the things that would be very interesting to look at from a very multidisciplinary way is time. Because one of the things as a paleontologist that I'm confronted with all the time is measurement of time. You know, people are always asking me, how old is it? Or the animals that I work on tend to be between about 80 million years old and 120 million years old. They say, how can you conceive of that, you know, that huge amount of time? But you know, with my other interests, I also know that there's other ways to look at time also. I mean, some of the astrophysicists, cosmologists, like my colleague Mike Shara here, who works at the Natural History Museum as well, that in discussions with other astrophysicists, cosmologists, as well as with Mike and stuff, that, you know, cosmologists are interested both in great expanses of time, far more than I am, like billions of years, as opposed to just millions of years, or they're interested in just the first few nanoseconds after the creation of the universe at the Big Bang. And one of them intimated to me one time, they said everything was all over by the first 2 nanoseconds. And then, as well as the sort of the theoretical ramifications of time as well, which we'll be hearing about also, just the mathematical formulations of that. We'll also be hearing, I think, a very different perspective from Peter, another one of my colleagues here, who is a scholar and an expert on the Hopi, and not just the Hopi, but other Native American groups as well, who have a very, very, you know, different cultural perspective of time, as do Jains, as do Buddhists, as do, you know, many other groups. And just looking at time in general and what it means. Finally, you know, Olga will represent the historical, visual sort of aspect of what time means, as you can see from the show, the pictures that are up here on the wall. So, one of the things that I'm most interested in, and really was sort of the thing that caused me to want to do this, is that when we talk about time, what are we measuring? I mean, what is it? That you know, how do we understand? Like, how do we talk about increments of time? I mean, I think that if you're to look at it purely from kind of the academics that I'm used to, you would say, well, we have sort of social scientists and ethnologists who look at time on a generational kind of way, at least within Western science. Then we have archaeologists who look at time on kind of a millennial time scale. Then paleontologists who look at it on sort of a millions and millions of years kinds of thing. Then we have astrophysicists who tend to look at it as billions of years kinds of thing. But within each of the different groups of people we have here, before we get into the nature of what time really is and how people really look at it, I'd like to just hear a little bit about what are the measures of time itself. Anybody can start. Jump in.
That's irresistible. I mean, one of the things that astrophysicists tend to do with most of our other professional colleagues who are interested in various kinds of stretches of time is the kind of arrogant little boy approach that is, my dad can beat up your dad with both hands tied behind his back. We do deal in billions of years. And in fact, we actually talk about trillions and quadrillions of years in a realistic sort of way. Now, the universe is only 13.7 billion years old. And it's actually 13.7 plus or minus 0.1, which is itself a remarkable thing to be able to say. And astrophysicists have determined that only in the last 10 years or so. Now, what in the world could I possibly talk about in 1 trillion years? What could be there? Well, there are stars that I can point at, including one that you can see with a small pair of binoculars in the southern hemisphere, the companion to Alpha Centauri, a little M dwarf star, a thing that's about 1/10 the mass of the Sun, that will still be in existence about 1 trillion years from now. It has that sort of kind of lifetime. It's a little star, but it's husbanding its fuel very carefully. So the hydrogen in its core will keep on fusing for that length of time. And it's a faint little guy, but it will still be here. And what about 1 quadrillion years from now? Well, even those stars will have burned out. but the ashes of the deaths of stars, including our own sun, which, by the way, only has about another 4 or 5 billion years to go. Okay, so we're just a passing fancy in the universe. The ashes of that star, our sun, will still not have reached 0 degrees. Will still be very, very slowly radiating a little bit of light a quadrillion years from now. Okay, so 1 trillion years is 1,000 billion. A quadrillion is 1,000,000 trillion years from now. Those are the kinds of time scales where we really do know what we're talking about. But what about longer time scales than that? What we seem to be seeing is the universe accelerating. It's not just expanding. We've known that since the 1920s or so. But the universe is actually expanding faster and faster. It's accelerating because every cubic centimeter of space is just chock-a-block full of an enormous amount of dark energy, stuff that we don't understand at all. It's pushing the universe apart faster and faster. And what that means is that in the very far distant future, the universe is going to become a very lonely place. Right now, when we look out at the night sky, we see lots of stars, but what we see far more of, at least with our more advanced telescopes like Hubble and then the James Webb Space Telescope coming along next, is galaxies. There are at least 100 billion galaxies in the universe, and each one is typically made up of about 100 billion stars. You multiply those two numbers, that's 1 with 22 zeros, and that's about equal to the number of grains of sand on all the beaches of the Earth. But a few trillion years from now in the future, even with Hubble or even with the James Webb Space Telescope or any telescope that we can conceive of, there'll be no galaxies out there because the universe will have expanded so much and accelerated so much that all of the galaxies will have disappeared beyond our event horizon. So there'll be no light coming from any of them. And we'll be very much alone, assuming that we're still here. Anything that has descended from us is still here. Now, Mark will probably tell you that species go away on time scales of millions of years. 10 million years is the number that seems to be bandied about.
Actually.
2, okay. Yeah. Well, okay, so we're talking about trillions, quadrillions, and quintillions of years, far, far into the very distant future. That's the kind of numbers that we deal with, the kind of future that we think about, and into the much far future, well beyond that, we really haven't a clue as to what's going to go on, what's going to happen, because once things start to expand that much, once space becomes that empty, once it's devoid of any kind of matter, it's very hard to even conceive of how you would measure time, how you would objectively measure time. You need vibrating atoms, pendulums, quartz crystals. You need something to do something to be able to measure time. And once space gets really, really, really empty and there's nothing there anymore, can you even measure time? Does the concept of time have any reality? What happens to it?
Well, I think that relates to the Hopi perspective.
Well, I think that is a good segue. It's interesting to ponder what time is in the first place, if you will. Can you even translate the general way that we use the term time effectively into other languages, even other European languages? There are clearly differences between French uses of the word temps and English uses of the word time. Of course, Worf's characterization of the Hopi language was that there was no concept that was directly similar to the way that time was used discursively in English. That's come under some criticism from some subsequent linguistic work, especially by a linguist named Malotki, who does indicate that Hopis are perfectly capable, and that's part of my experience too, of speaking about what we might in English call the past and the future and the present, even though they may have a different sort of philosophical take on those things. And even though they may, their sense of the sort of the ever-becomingness of experience may be filled with a sort of a sense of predestination, that the continuous flow of time isn't separate from any kind of universal intentionality or meaningfulness, but that it's saturated with that idea, and that as time, as it were, comes to us in the present, it's already been the events that are associated with it have already been predestined, and it's simply we're getting to what's already been prescribed since the beginning of time. But in any event, I think that leads me also to think about the relationship between how we characterize time cross-culturally in a broader sense. It's obviously an abstract notion in and of itself, and to contemplate measuring it requires conceptualizing it a priori in a certain sort of way, and to say that we can count it. We can go from 1 to whatever, whether it's a quintillion or whatever. Nonetheless, we can arrange it as it were in space and count its lengths. Obviously, the interrelationship between time and space is very much a part of the way that we conceptualize time on an ordinary, everyday, experiential basis. We frequently speak in terms of lengths and so forth. But I think it's pretty standardly the case cross-culturally that you do have this conjoint sense of linear time and cyclical time, of time that's either sort of modeled by a geometrical line in the way that we tend to think about it mathematically, or else in a circle. And where that particular desire comes from is, I think is subject to debate. Obviously, we experience aspects of both in our own lifetimes. We're born, we grow up, we grow old, we die. But we also see the cycle of the seasons every year, if year is the appropriate measure that we're thinking of in a particular cultural context. So depending upon how you sort of analyze that culturally, I think there's some persuasive value to one of my former teachers, Edmund Leach's notion of the fact that cyclical time is basically a model that is derived from religion. And fundamentally what it says is that inasmuch as day is opposed to night, as winter is opposed to summer, or whatever other sorts of oppositions can marshal your experience of annual time and daily time and so on and so forth, we're going to say, as believers in our particular religion, that life is opposed to death in the same way. And so we transcend death by saying it's like sleep, it's like night. Day will always come back. Perhaps we'll get reincarnated, if that's part of our religious system. But in any event, we will try to deny the reality of our expectation of death by suggesting that we can control time by articulating measures of it. And I think that is something that comes out of ritual before it comes out of science, although the two are clearly linked. And if you can take any number of examples, but I'm thinking particularly of the Mayan long count calendar, where basically, I'm sure you could do it into the quintillions, but where there is a 13, 20-year cycle that repeats itself every 260 years, and events then that occur at a particular moment of the cycle will reoccur, or they will be revisited the next time that cycle comes around. That, to me, serves as a kind of a useful metaphor of how measuring time, how producing calendars of time, or cutting up time into hours and minutes and seconds and so forth, is basically a desire by human beings to control a flow of experience that is ultimately uncontrollable. If you say that you are going to predestine all events, which is in a sense what Hopi phenomenology does, or the Mayan calendar does in a somewhat different way, it comes down to the same principle, I think, that via a ritual organization, a symbolic organization of the flow of experience, you're trying to control events as they occur. So then, when we have our annual rituals of one kind or another, whether it's a midwinter ceremony or for the Hopis, a Kachina ceremony or a snake ceremony, basically you're restoring the world to a time that exceeds the ordinary flow of linear time and rebalances everything, restores everything to a sort of a place of timelessness when the world was new, when it was created. And this seems to me it's somewhat similar to the notion of, in Australian Aboriginal societies, of going walkabout to the every when time didn't exist, but the world was in a moment of creation, and you can sort of get back in sensory touch with that via the particular ritual context that you enter into.
So I think this idea of cyclicity is a pretty interesting. Olga, maybe you could speak to that a little bit in the visual arts, because if we look at so much of the historic tradition of visual arts and things, in narrative paintings and everything else has to do with the cyclicity aspect of it.
No, I actually wanted to say something different.
Go for it.
because I want to say about measurement of time. If you said about uncontrollable process that we cannot affect anything, but and I would like I have friends. They are biologists for NASA, and they both interested in concept of time. Alexei Sharov, he has several papers on time and several works on time. And what I know from him that in biology, actually time measured not in minutes or seconds. They measure it in cell divisions. And actually, for example, reptiles, frogs, snakes, when the pregnancy of this species could be affected, length of pregnancy, just by temperature. And time of pregnancy is different. But if we look at other objects, for example, we take the absolutely identical objects and put it in different environment. One very controlled environment with temperature, with whatever, and other just throw it somewhere. So they will be affected differently in the particular and it was not, they will not be affected by time itself, but the environment, but information that surrounds them. So this is the question. Should we measure time just this question between Newtonian time, subjective time, individual time, biological time? So in every, as you said, in every field, we try to find our way to measure time, because we cannot apply something uncontrollable on all these objects that we would like to research. So sometimes it's, from my point of view, it's controllable.
Well, I think that's that's a good case. I mean, counting time by cell divisions and something which is becoming pretty interesting these days as far as in model organisms to be able to look at aging and things like that. But it kind of gets to something which that I've been really interested in for the last several years, and that's how we count time to look at these major events that occur. Because that one of the areas which we're researching is that the extinction event that happened at the end of the Cretaceous period when the non-avian dinosaurs became extinct. And that there's different ideas out there of why this happened. I mean, the prevailing one is that an asteroid hit the planet at about 65.4 million years ago. And that off Yucatan Peninsula, and we have good evidence that happened. I mean, that's a fact. I mean, okay, so that's not something we argue about. But then it becomes, do we argue whether or not that happened that caused the extinction of the non-avian dinosaurs? And that idea, that scenario predicts that this was catastrophic worldwide. It happened in just a couple of minutes, that basically all this energy was released, the universe glowed, or the atmosphere glowed, everything was cooked except the things that lived. And that you had this event. Well, for me to look at that, to be able to say, well, that predicts something really fast is happening, whereas that the alternative scenario is that the extinction event was much slower. Well, that requires you then to define what you call fast and what you call slow. And unfortunately, with the best tools that we have, which are radiometric clocks, either uranium dating or argon-argon dating, that the variance you have at that time period is around, the best dates we have is about 750,000 years. So that is the click of 1 second if you have a regular watch. So we can talk about events which happened longer than 750,000 years or shorter than 750,000 years. So if we look at everything that's happened on the planet in the last 750,000 years, from the origin of our own kind to the 13 great glacial advances and retreats and all this other kind of thing, that's all compressed into the limit that we can tell time right there. So the question then to me becomes is that I'm not saying that the asteroid didn't cause this extinction, but at the same time, it's sort of an intractable thing because we can't choose between this super fast thing within a day that this all happened or something that happened within 750,000 years. So we're stuck with that. And as we move back in time for the history of life, looking at it, it just gets worse because of the variance in the numbers we have get much greater. So that the great extinction that happens at the boundary between the Permian and the Triassic, roughly around 300 million years ago, that then we can tell time in a 2 million year variance. So it just doesn't do us much good to talk about these vast things. But I think that, moving from that, let's hear a little bit about just sort of purely mathematical description of how time changes and differs and is related to mass.
I was actually hoping I could comment on some of the other
Of course.
You
can do anything you want.
There's actually a lot that's come up already, obviously, and we could, any one of these little 5-minute talks, we could expand into a whole book. I'm sure it's been done, actually. But I wanted to comment first on what Mike was saying about the example, I could beat up your dad with or my dad could beat up yours with my hands tied behind his back. A physicist could certainly do that to a cosmologist. Physical time is measured, in fundamental physics at least. I think the Large Hadron Collider and effects measured down to maybe 10 to the minus 25 seconds, something like that. And conversely, the longest time span ever probed is something like 10 to the 33 years in understanding the decay, the possible decay of the proton. So that just leaves astrophysicists in the dust. I mean, a trillion years is nothing to 10 to the 50, whatever that turns out to be. And a second comment, but it's actually related to that, is understanding this diversity of our views of time. And I think that's something actually that really pertains to the deep mystery that time poses, even just in a technical sense, to a theoretical physicist. One of the great issues in physics is why the physical notion of time is just so mismatched with our other notions of time. Those certainly in Western culture, let alone those we see in the other cultures that we're lucky enough to inhabit the planet with. And ironically, kind of the answer that most physicists would give to that disconnect is to worsen the disconnect, is to make things even worse, to go even further from our conventional notions of time as progressive or linear versus cyclic. Those all just don't even enter into the emerging idea, literally the emerging idea, that time is itself an emergent concept, that the universe is at root timeless, spaceless also, and that time kind of bootstraps itself into existence. And you'll notice that all the terms I use for this are themselves situated within time. Time is bootstrapping, but that's something that happens in time. The ing connotes something in time. So our language is already becoming stretched here, and it's hard even to conceive a process producing time and therefore cannot operate within it. But how can it then be a process? And I presume we'll come back to some of those deep issues as we go around. But one thought that goes into that is, Olga almost alluded to it, or at least touched on it, was the way we separate the universe. We divide it. We conventionally might call a physical system a system and the environment, or the organism and the environment. It's always this kind of split. We split things up. There's the system here and the system there. There's the person here as an individual. There's a person there. And then we seek to relate those kinds of notions of time and those different subsystems to one another. And that's actually one of the leading ideas for understanding what time is, that it actually comes from those interrelationships among the subsystems in the universe, that it doesn't exist, time doesn't exist in the abstract as an absolute concept. It's something that we introduce in science and in language and in art and so forth as a way to describe interrelationships among things. I called it kind of a common currency approach, that we use money as a way to avoid all the barter transactions that we would have to conduct. I'd sell my magazine for 3 of your sheep, and then I'd turn the sheep over, and I gain entrance to the museum or whatever. To avoid all that, we reduce everything to the common currency of the dollar, or the euro, or the real, or whatever. Time may itself be some kind of common currency among these different domains of human experience.
Aren't you really using, it wouldn't, I mean, I hate to sound Jesuan, but wouldn't it,
Please.
instead of being like anthropomorphizing, I mean, aren't you really talking about anthropomorphizing the concept of time, that basically it's just a creation that we do, and that has very little to do with the actual existence of some other entity that might, you know, well, you used the word a priori before.
First of all, I can't avoid anthropomorphizing because I'm a human being, so
That's what, all of us are striving to do something which is totally, has very little to do with anything that exists outside of ourselves.
right. I mean, that's a deep question. It goes to the whole practice of science is done. But I would suggest that, first of all, we can't avoid that anthropomorphizing, so I might as well just run with that idea. Second, to the extent we have any kind of objective understanding of what time is, the mathematical understanding that he's prompted me with, it tells us that the universe is timeless. So time has to emerge somehow. It's not at the fundamental level, in other words. It has to emerge in one of the other levels that reality presents to us. And maybe it doesn't really emerge at the human level. So it's objective in the sense that maybe it emerges at the particle level or the string level or whatever the universe is made out of. In other words, I think there's an objective sense, at least within physics, you can talk about time as being without any kind of...
You don't need a perceiver, in other words.
Right. So the system doesn't have to be a living system. The subsystem doesn't have to be living. It doesn't have to be capable of self-consciousness, as we hopefully are. It's just a subsystem of some sort interacting with another subsystem. And our own artificial categories come in to the extent that those subsystems are things that we define. But once you do that definition, then it's an objective property. I don't know if I'm making any sense.
No.
Maybe, Mike, you can help fill in on this.
It's a very difficult concept that physicists have been grappling with now for 15 or 20 years to try and get your hands around it. Let me take one step back and talk about something that's a little more objective, something that is extremely measurable, that I think all physicists agree with today, and that is the rate at which clocks tick is not a constant in the universe. If you and I could somehow put on extraordinarily accurate atomic watches on our wrists, synchronize those watches somehow by sending light signals back and forth, and then one of us would simply sit in this room and the other would go for a walk around 81st or 82nd Street and come back here and compare clocks, our clocks would no longer be perfectly synchronized. Einstein summed it up very beautifully by saying that you can move through space, you can move through time, and we all do. And it turns out that you end up moving through the thing that he called space-time, the four-dimensional construct, essentially at a constant speed. But the faster you move through space, the slower you move through time, so that you end up moving at a constant speed. Everybody and everything, every photon, every person, every bacterium in the universe moves essentially at a constant speed through space-time. A logical consequence of this, one of the most fabulous and extraordinary consequences of this, is the gorgeous twins paradox that he came up with. And that is that two twins born at exactly the same instant of the same mother, say by C-section, pulled out simultaneously. One is taken by her baby nurse and taken aboard a spaceship immediately and flies off to a star 20 light years away, almost at the speed of light, 99.99999% the speed of light, reaches that star, stops, turns around, and comes back. Now, for both the baby and the nurse on board that starship, time is ticking away, and there are cell divisions going on, and the cell divisions of the baby and the baby nurse are happening at the same rate. They're not moving with respect to each other. It takes 20 years to get out there at the speed of light, 20 years to come back. So 40 years have elapsed on Earth. And the 40-year-old twin is waiting on Earth for her twin to come back. And as the spaceship lands, the door is open, and the baby nurse carries the twin, who's been on the spaceship, off. And that twin is only a few minutes old. And that seems completely crazy, ludicrous, idiotic. But what's happened is that the nurse and the twin taken on the spaceship have moved rapidly through space, and as a result have moved very slowly through time. So clocks don't tick at the same rate if they're not at the same place in space-time, not moving together with each other. And that is not a theory. That's been extremely well measured. Atomic clocks have been put on a 747 and flown around the world, come back to the same starting point in Colorado, and the clock on the 747 ticked a few billionths of a second less than the clock that remained behind. Of course, that's because the 747 wasn't moving anywhere close to the speed of light. The closer you get to the speed of light, the slower your clock ticks relative to a clock that's stationary with respect to the rest of the universe. That in itself is a hard concept to define. Astrophysicists think that it's stationary with respect to all the galaxies or the microwave background radiation, a kind of rest frame or a pair of rest frames in the universe. But the objective reality is that clocks do not tick at the same rate if you're moving at different speeds. We see that also with elementary particles all the time. Particles coming down through the atmosphere, mesons, decay far too slowly relative to mesons at rest, and that's because they're, again, moving nearly at the speed of light. And I'll just finish by noting that there is one amongst us, a Russian cosmonaut, who in fact has experienced this more than anyone else. He's been in Earth orbit, I think, a year and a half, longer than any other human being. And as a result, he has aged several millionths of a second less than he would have had he remained here on Earth.
May I say something about objective reality, since you've raised that dirty word? It strikes me that, in discourse about an asteroid hitting the Earth 65 million years ago, or in calculating something 3 to the minus 33 or whatever, or in even Einstein's twins example, we have to speak with the perspective of a subject. This goes to your question of do you need a subject to perceive time? I was just thinking about all of the discourse that we have presented, and I can't imagine that it could possibly have occurred. And the discourse is about time. It can't possibly have occurred in, say, 1890. Virtually none of the statements that were made could have occurred at a different moment in what we consider to be sort of an absolute progression of time. So I wonder what that does to their sort of the ontological reality of the statements that we're making about some of those temporal processes.
I don't think it changes the reality of the fact that time is stretchy. We just weren't aware of it in 1890. The fact is we've now come to understand these concepts, but I don't think that in any way changes the reality of them. Stretchy time existed 13 billion years ago. There just were no humans around to do the experiments to check on it.
Or to talk about it.
Sure.
And if we talk about it 300 years from now in a totally different way, will even these statements have the same kind of relationship to what we are assuming is an objective reality?
Possible to know.
One thing that relates to that is if we go into the far future that Mike was describing of the accelerating universe and the emptying out of space, there will come a point where the Big Bang is hidden from our view. We'll be unable to perceive any of the evidence for the Big Bang. So that idea of the universe having our universe at least having a beginning in the finite past will become invisible to even the most objective experimentation in, 10 billion years, something like that.
I think it's about 10 to the 12, so...
Okay.
Okay.
10, 12.
But it hardly matters.
Yeah.
It hardly matters.
One thing I wanted to just footnote the example of the cosmonaut, because I think it's fun to think about. It does not totally relating to the rest of the tenor of the conversation, is you don't have to think about the cosmonaut having aged less than the rest of us, bless him. You can just go out and throw a ball in the air, because the gravity that we perceive is also something that comes about from the distortion of time, in this case caused by the presence of the Earth.
You have his full and undivided attention.
Yes. So, in Einstein's general theory of relativity, the force that we perceive, that we call gravity, is caused precisely by a distortion to our notions of space and time, mostly actually in our own experience to the distortion of time. So we can talk afterwards because it's somewhat of an extended 15-minute
We'll
description.
give a little overview of it.
essentially, when you throw a ball in the air and it accelerates back down, the ball, I'm going to anthropomorphize it, but actually there is a rigorous sense that this is true. The ball wants to stay further away from the center of the Earth. That's where time ticks more slowly. So the ball wants to maximize the length of its trajectory. It tends to be slower at the top and faster at the bottom of its path. Now, there's a way to say that in words that don't imply the ball has some kind of little homunculus in it that's making these kinds of decisions, but the fact that balls accelerate toward the center is precisely because of the exact effect that Mike was talking about, the distortion of time. Everyone's got his or her own clock. We all go into the future at our own pace. Mine somewhat slower than most people's, but
Until you've had your morning coffee.
right, exactly.
So if it accelerates, what you're saying is that the rate at which it falls, the acceleration toward by gravity,
Right.
then the increased rate of acceleration and the time is decreased.
For the ball, the time is actually increased. The ball, a straight line, according to Einstein, a straight line through space-time, this combined thing of space-time, actually maximizes its length. Normally, we think of a straight line through space as being the minimal length between two things. In space-time, actually, it's the maximal length because of the way the equations work out. And the ball will maximize the length of its path through space-time by spending more time away from the center of the Earth. Like I said, it's something if we'd have Blackboard, I could show you.
Now, if you think that's a smack in the head, I'll give you a better one, okay? Or at least as good. All right. There's something really spooky in physics called the uncertainty principle. And the uncertainty principle states that you can't measure anything with arbitrary precision. There's uncertainty built into almost everything. And I'll anthropomorphize this again by taking a bookkeeper who at 5:01 Friday afternoon steals all the cash out of the till and goes to the racetrack. And if she's lucky, she'll put down, $100 on piano legs in the fourth race, and that horse will come through. And then at 8:59 Monday morning, she's going to be able to stick all the money back in the till and maybe even keep the change. Well, the same sort of thing happens on a regular basis throughout the universe. The universe is so chock-a-block full of energy that we can't actually detect or measure. Think of it as a kind of roiling sea of energy, that particles and antiparticles are created essentially out of nothingness everywhere all the time. But they don't live very long. They only live this 10 to the minus 30 or so seconds, and then the particle and antiparticle recreate, or rather recombine, and that's like the bookkeeper putting the money back in the till at 8:59 on Monday morning, and nobody knows the difference. So it's as if conservation of energy and matter weren't violated. Okay? Now, why am I getting to this? Well, this was understood first by some physicists, German physicists back in the early 20s, and their understanding was that you couldn't measure, say, the energy or say the momentum and the position of a particle with arbitrary accuracy, or you couldn't measure how much energy a particle had in an arbitrarily short length of time. What that says is the fact that the product of the uncertainty in energy and the product of, with another number, the uncertainty in time, the fact that that number isn't zero, that there is always some uncertainty, and the size of that number, something called Planck's constant, tells you that the universe is grainy. The universe is not smooth. And what that means is that space is probably grainy. Now, we all think of, say, walking on this carpet, and this carpet is smooth, but of course it's not. It's got lumps and bumps, and if you could take an electron microscope and focus on one of the fibers, you'd see that there are lots of little electrons and protons and what have you hopping up and down. So each of the fibers in the carpet is a kind of graininess, so we're walking on a kind of graininess. It appears from the uncertainty principle that space is fundamentally grainy, and what's worse, time is fundamentally grainy. So imagine trying to walk across a river and there's lots of stones in the river. Well, you can only step on the stones, okay? You're not allowed to step on the river. So that kind of graininess translates right down to this very microscopic level at the 10 to the minus 33 meter level, and probably the 10 to the minus 44 second level. So there appears to be a smallest tick of the clock, or a shortest tick of the clock in the universe, around 10 to the minus 44 seconds. And the smallest distance between 2 points. You can't keep on subdividing a distance arbitrarily, okay, down to as small a number as you want. The universe appears to be grainy, and especially time appears to be grainy, finite ticks of the clock, right down at the very smallest level.
But doesn't that have a lot to do with timescales itself? You know, in the sense that, fractal geometry. I mean, it's just that you could say that, well, what's the length of this coffee table? And I mean, from a fractal geometry point of view, you could say it's infinite because it's just that what you're using to measure it. If you use a yardstick, it's going to be one thing. If you use like a more sensitive tool, it's going to be another thing. But and if you use an electron microscope, it's going to be even longer because you can actually measure all these kind of little things.
Right.
The question is that where does it stop?
And
At
the answer from
at 10 to the minus 44
appears to be from Planck's constant at 10 to the minus 44 centimeters. It appears to stop.
This whole idea of time scales and measuring time and distance is something which I find really interesting, and I'd like to hear it from Peter and Olga's perspective from a kind of visual and sociological point of view, because it's really been pulled out to me working in a lot of different communities in the world and stuff. Is some of the places that I work in Tibet and in Laos, it's where average life expectancy is only about 35 years for people. And you talk, that they talk about things far different than we do in our culture, where life expectancy is twice that and stuff. About, that their grandparents being really in the distant past, which I'm sure, like a lot of us here, have grandparents who are still alive and can speak to things that happened in the 1920s and 1930s and that kind of thing. And it's just that they talk about that the same way that, at least within my nuclear family, that people talk about stuff that happened in the late 1800s from hearing from their parents and stuff. So that it just seems that aspect of time is a really different one from a different cultural tradition and stuff, as well as in the way in which the way that we look at the progression of visual arts over the last 150 years. So.
Yeah, I think the perception of generational time is a significant component, certainly of the sociological apprehension of time, cross-culturally. In terms of life expectancy, I think that's going to vary a lot cross-culturally too. So, for example, Hopis, constantly say nowadays, in the past we used to live a lot longer. And they blame it on, the modern diet that's been introduced from the outside world. There are some objective indications that that's the case, that there were a lot of people, say around 1930 or 40, who were in their late 90s and older than that as well. So I think they certainly tend to see generational patterns as more similar to our own lengths of generation. But they're concerned with how the past is brought forward, how it's transmitted from one generation to the next. I think, again, that's something that varies a great deal cross-culturally. And if your culture tends to emphasize more the cyclical sort of repeating aspect of time, that we're all on a cosmic wheel of some sort or another, then that may be more or less calibrated back into the measurable past. I'm thinking, for example, of the number of generations that people will count in different cultures. Hopis don't count back very far. Once you get past a grandparental or what we would call a great-grandparental level, things become much more sort of melded in terms of those sorts of discriminations. And frequently, that doesn't mean there isn't a very precise kind of memory about certain kinds of events. And it was really interesting to me to discover that people could start talking about a particular event in the past, and it was as if they were speaking about it from their own experience. But I knew from other sorts of patterns of information, they were talking about something that happened 300 years ago, and I can date it via the documentary record, for example, in archives. That sort of sense of the past is really nonetheless very powerful in that context. But in terms of measuring the time backwards from the present, they're not terribly interested in that kind of thing. Whereas the Kwakwaka'wakw up in Vancouver Island, people who used to be called Kwakiutl, or indigenous Hawaiians, tend to trace generations back really very precisely, back maybe 2,000, 2,400 years in a way that, say, ordinary, unless you are a monarch, you wouldn't do in this society. So, and again, I think it's interesting to raise that question of generationality, as it were. You mentioned your family we'll speak about things in the 1800s. How much further back than that does it go? How many names of ancestors does one know, for example? I mean, I know that past my own grandparents, I'm pretty well lost. I can sort of recapture it from census records, but they're meaningless names because they don't have any resonance. They're just indexical of who the actual person was at the time, but they don't have any sort of social salience to me. So,
what is the definition of time for you?
I like to think of time in terms of vibrations of the nuclei of atoms, which is, I guess, the geekiest way of doing it, but it's also by far the most precise way we have today. That's how atomic clocks work. It's really a certain number of vibrations of a certain kind of atom.
Of time, or actually the definition of time?
No, you're right. That's certainly the measurement of time, but I don't think you can separate the measurement of something in some sense from its reality. At least our perception is one of time flowing in a linear sense forward, and we can measure that extraordinarily precisely using these kinds of technologies. Now, I also try to remind myself when I get stuck on that kind of definition that things that we also think of that are very deeply embedded in our intuition are really meaningless. For example, the concept of simultaneity. Okay? We can all think of two events that happened at exactly the same time. And in particular, if I take two lead balls and drop them from the same height towards the table, you would expect that they would hit the table simultaneously. Or if you stand, aside from the set of railway tracks and you see two lightning bolts hit the train tracks simultaneously, you would think everyone would see the same thing simultaneously. That's nonsense. That's just wrong. It's not true. Someone on board a train racing down those tracks at, say, half the speed of light sees the lightning bolt on the right side hit well before the lightning bolt on the left side. And you then have to ask the question, who's right? Is it the moving observer or is it the stationary observer? And the answer is both. Okay? And that's because this paradox is resolved by the fact that there is no such thing as simultaneity. The concept is meaningless. It's wrong. That was first demonstrated by Einstein, and all physicists agree on that today. Now, if we can't agree on simultaneity, okay, or if we can't agree that the concept of simultaneity is a meaningless one, then in some sense all of the rest of our concepts of time dissolve. Okay? The whole basis on which we think we understand time as human beings is really a basis of sand, and our castle all comes crushing down. So the real answer to your question is, I can't answer that question.
Which is always the best answer.
I thought you had an answer that was a bit different when you were describing time and the universe and there's no time. At that point, I thought you were saying something about that was different.
It depends what level you're speaking on. Obviously, in our everyday experience or the experience of someone who's lucky enough to be on a train moving at half the speed of light, unlike the trains in the city. At that level, it's really at a deeper level whether time, and we're talking deep level, at which time might have no, it might just fall through your fingers. You don't have anything of it. The way I like to think of time, and it's actually related in a quite interesting way to this whole question of lightning bolts and simultaneity, is time as an ordering device. It's like those psychological tests, maybe you can help us with the names of those, where you're given 20 frames of a story, and you're supposed to order it, and it's a way that makes sense. So someone lights a match, and then there's a fire rather than there's a fire and then they light the match kind of thing. It allows you to order what would otherwise be a completely jumbled series of events. So if you were to take all the physical events in the entire universe and just dump them on the table like a jigsaw puzzle and try to order them, you would find that in that process, this idea of time would help you. Time would act as a device to help you order things. And that actually comes up in this whole question of lightning bolts, because although the simultaneity is relative among the different observers, what is not relative among different observers is our sense of a cause-effect ordering. So if I see the billiard ball, the red billiard ball hit the black one and send it careening off toward the table, everyone else will also agree that they see the red billiard ball hit the black rather than the other way around. Or if my brother took my peanut butter and jelly sandwich, and everyone would agree on that, and we could really punish him for doing that. So there's an objectivity to those kinds of relationships that comes about from the kind of thought experiment that Mike's describing.
I think there's a way in what you've hinted at also, and I think maybe we need some philosophy if we're going to be able to have definitions that we can agree on, or maybe disagree on, but at least have definitions. But it struck me that the ordering principle in this psychological test, it resonates with Ricoeur's notion about the need for narrative to articulate our sense of temporality, and that he argues that temporality is the fundamental sort of diagnostic definition of what it means to be human, and we make that sense of temporality via narrative, whether it's a biographical narrative or an historical narrative, more broadly speaking, or whatever. And the other philosopher whose name I'll take in vain is Wittgenstein, and that is, Mike, you can't say I can't answer that. It's not acceptable. The meaning of a word, in his sense, is its use. So how do we use that sense? That's kind of what I was getting at earlier with this sort of cultural notions about what it is that we're talking about. If we agree that we're talking about something that we all can point at in some sense, ostensibly, then we've got to be able to say what the broad outlines of that thing are. And so, I think we've got to do an inventory of the ways that we use that word time in our ordinary language, and then we'd have to say, well, that's pretty much what the definition amounts to. Even if we use it idiosyncratically, whether we're physicists or anthropologists or via a whole range of other sort of senses that distinguish our perspective on things. Yeah.
Okay, I would like first to say something on definition, on measurement of time in art. I would like to draw your attention to Elliot Kaufman works. For example, he takes, this is waves, this is different stages of sky. So he takes these frames and put it together, and he measures time in these changes. This is Linda Stillman. It's every day she takes, paint this little square of the sky. And this is actually 2006, and it's the calendar. So she measured time in days. And if we talk about traditional view of time as a circle, it's usually we see these circles everywhere in calendars, in wheels of fortune, wheels of life, in Buddhism, and everywhere. This figure of this very, very important symbol of Ouroboros, the snake that eating its own tail, and which interpreted in almost all ancient symbolic drawings. But also I would like to say something on definition of time. So, and I would like to show something. That's on outside poster. There are it's outside of this room, and the different visual metaphors of time, how we define time in everyday life. For example, time as a river, time as a circle, time as an arrow, and I included sometimes time as an ocean. It's very popular in music to define time as an ocean. And time as destruction, time as edging. We define, so if we start to think about time, we see that time is actually a very complex phenomenon that depends on other phenomena. And it could not be defined just very simply because everybody sees it differently. For example, it depends on memory. We are able to memorize things, so we are able to create concept of time. If we don't have memory, we cannot create the concept of time. We see changes and we memorize them, we store them, we analyze them. All our abilities give us this concept of time. So, and in this poster, I included this image that it's René Magritte. It's René Magritte. It's man looking in the mirror and seeing his back, not his face. It's very famous painting, and he is surrealist, and from my point of view, I like him much more than Salvador Dali. Although the most famous interpretation of time is Salvador Dali interpretation, where he connected clock, just time as a clock, visual metaphor, very, very simple, to flow. And that's they flow from some surfaces. And René Magritte has his interpretation of time, and it's also there on the poster, but this he never connected to time. It calls reproduction forbidden. Reproduction forbidden, prohibited. It's the name of the painting. But from my point of view, it's the absolute visual metaphor of human perception of time. We look anxiously ahead to our future, but what we see our own memory. We see only our back. And when you start to analyze this painting, you start to see that it's almost work like a formula, like an equation. Future equals past plus our desire. But actually, about psychoanalysis, what actually I personally think that it's not so much our desire to be there as our fear, our disappearance from there, our death. And our concept of time, it's actually connected to our fear of death very, very closely. It's a lot of right now talking about immortality, nanotechnology, that we could live forever or whatever, although... So this is one formula. Future equal past plus our desire. But also when I thought about this causality equation, yes, so it's, and you said it, crime and punishment. And I personally, when I wrote about it, I put it because in my memory it's implanted, crime and punishment, Dostoevsky. I'm Russian. One of the first books that I really liked and really was impressed, and it was in all our school books that we had to read, and it's everything. So, and it was morality tale. But when I wrote about it, and my co-writer, Julia Druk, she edited it. She you absolutely, probably you understand that I need heavy editing of my texts. So I need co-writer, not I need just editor. So she edited it's crime, then punishment. And I said, no, Julia, it's actually crime and punishment. And said, no. And I understood her from the just novel title or morality tale, it became also an equation. Crime, then punishment. Crime and punishment are static things. And time is in connection between them. And actually also, past and future is static things, where the time in desire or in fear, in connection between them. This, it doesn't go to precise definition, but it goes to visual definition. And I think that we use our visual language probably much more often than we use verbal language. We talk to ourselves, from my point of view, in visual language. For example, when you see chair, you recognize it's a chair. But you don't say, chair is the object that I can sit in 4 legs, and no, you recognize. So, and from my point of view, because of this, visual metaphors is very important. If in the beginning of this of past century already, emerged one very strong visual metaphor of time, arrow of time. And it right now more and more implanted in our memory from our school years. And from my point of view, it's not very correct. It does not say, it's simple. It simplifies very many things. And we like simple things. We like squares, we like straight lines and perfect circles, but it does not say us about complexity of this idea. That's probably it.
On the question of language, I think that's very significant from a variety of perspectives, whether it's verbal or visual. Note that the way that we tend to have been using time in this discussion is as a noun. It can be a verb, of course. You can time something. Most of the usages that we have of it is as a thing that you can look at and somehow define. Part of the difficulty, I think, with translating that concept into other languages depends upon whether the same kind of emphasis upon nominal things versus verbal processes is present in one of those languages. And here I'm thinking especially of Hopi, which tends to be a language which is more composed of verbs in various states, various processes, than it is composed of nouns. The same is true of Navajo, where, for example, there are something like, theoretically, 356,000 endings on the verb to go. But the verb to go is the principal verb in Navajo rather than the verb to be, which is associated with nominal states, with things. And in practice, I think I learned about this. This is a tough sort of notion to think about in the context of Hopi describing certain events. And frequently those events, or events which are felt to be aesthetically pleasing or desirable or something like that, are captured in personal names. Hopi names are like little haikus. They're sort of representations of a particular or images of a particular process a lot of the time. So when somebody was explaining a particular name to me, which which literally means whiteness turning around in a line. And it refers to a particular dance, a kachina dance, a dance of masked dancers, who reach a certain point in the performance, and each of them successively turns around in a line. Their bodies, the top of half of their bodies are painted white, so you see that happening in that process. Now, English can do that. English can do it with nouns, or even maybe in some verbs. But it's not ordinarily the kind of thing phenomenologically that English would pick out to describe about those kinds of aspects of phenomenal experience. And just one other example, a name that I had puzzled over for years, long years, was the name of Kikmonwi, the village chief of Olga until about 1960, and his name was Dawakwap Diwa. Diwa is a male name ending that may be associated with a verbal indication of process. Dawa is the word for sun, and incidentally the word for clock. Okay, now that they have clocks, Dawa is a clock. Kwap is a plural term, meaning several things get put above. So you have Dawa, sun, several things get put above, and then the verbal male name ending. So I said recently to a friend, I've never been able to figure this out. You've only got one Dawa, you haven't got many Dawas that are getting put on above. Why is it a plural? Why is there a plural in the verbal aspect of that? And he said, oh, well, that's obvious. Why didn't you figure that out? Yeah. It's because it refers to the sun at various junctures in its passage across the sky, that it's been put up. And so, again, the visual imagery of that was very revealing about sort of the way that Hopis think phenomenologically about that kind of process. And I think, again, it's associated with their language. But I think, again, we would tend to think of the sun in a particular spot. We can certainly imagine the process, talk about the process and so forth. But in our ordinary usages, we would typically tend to think of it as fixed here, and then moving to there, and so forth, and rather than the processual aspect itself. And I think maybe the same thing, is a problem in understanding what time could be as we try to translate it into other languages, which are, non-European languages.
Do these? I was curious. Like you talked before, and what you just said. Are you just looking at this with amusement? I mean, because you came up with. You're a scientist.
Not amusement at all. I mean, the workings of the human mind are fabulous. I have no beginnings of understandings of how they function, and the perceptions, the completely different perception by different peoples of what can be conceived of as exactly the same process are, to me, fascinating. So no amusement.
You talked about objective reality.
Right. And that's something that I try to understand or put my arms around every day. I try to understand the universe. I try to understand the processes going on in the universe. And I try to make predictions about what's going to happen in the universe using the laws that I think that govern the universe. But I'm very much aware that there are different perceptions. Einstein may have summed it up best when he was asked often about time and relativity. And one of the best things he ever said, in my opinion, was, you sit on a hot stove for a second, it seems like an hour. A pretty girl sits in your lap for an hour, it seems like just a second. That's relativity and time.
Great. I think with that, we'll end it. And I think we have
we have a question and answer.
Yeah, we have a little time for some questions.
Before we go on, I have a couple of things to say. One is we have books for sale back here afterwards, and also our dialogue, which is available to anyone who would like one, which was edited by Adam Ludwig on our staff. Did a magnificent job on it, and it deals with our mathematics, particularly with our mathematics series. So you should pick one up on the way out.
Hello. Once again, I don't know if you... okay, this is better probably. Once again, I haven't been coming here too long, but
Can you say who you are?
Herb Goldman. I live in Queens. The panel just doesn't, no matter the subject, doesn't disappoint. But when I saw that the subject was time, I was thinking that there were going to be a whole bunch of physicists here, and I was thinking of the following kind of thing. Supposing before the Big Bang time existed, and supposing after the Big Bang, I'm assuming that happened, time was invented or created or happened. So I was beginning to think that what's really fundamental? Supposing time happened after the Big Bang happened or simultaneously with, and I was asking myself, what's really fundamental? And I was thinking, well, from what I know, entropy is pretty fundamental. The process by which things go to disorder. And if there wasn't any time, I guess things wouldn't become disordered. And I happened to Google it, and there actually was, I put in on the search, entropy and time. And I was really surprised to come up with some stuff, some papers that have been written. And I was thinking, well, what else seems to be fundamental in nature? I was thinking, well, from what I know, maybe the speed of light is, maybe. And now I think I just want to sit down, and I wonder if the physicists could take a crack at what's really fundamental, and maybe answer the question in a way, the chicken and egg question, which came first of the things that are fundamental. And now I better sit down. Thank you.
Okay. Well, the chicken and egg must have co-evolved, right?
Egg is first, actually. Present in crocodiles.
That's right. There does seem to be an arrow of time in the universe. That is, time seems to run forward and not backwards. And yes, the universe seems to have started from a state of relatively high order and seems to be going to a state of disorder. That's certainly a valid observation, and entropy seems to work in only one direction. We observe that, we see that, and that's an objective reality. At least that's what we perceive of as being objective reality. Why that is so is a very fundamental set of questions in nature. Why things are either constant or why they move only in one direction are very, very basic questions that I think we don't have a theory of physics today that is able to explain those things a priori. If we had it, we would have probably the theory of everything. We'd have either a quantum string theory, or we'd have some kind of theory which allowed us to predict into the far future what was going on, probably even more interesting into the very far distant past, that is right up to the Big Bang. And the fact that we see all sorts of singularities, or equations imply all sorts of singularities, that is 1 over zeros giving us infinities, back near the time of the Big Bang, means that our theories aren't working. They're broken. That we're ignoring something fundamental and basic. That's something that I think all physicists agree on today. We don't have a theory good enough to take us right back to the beginning, and yes, the first 2 or 3 billionths of a second are where most of the action or much of the action happened. And with a valid theory, we could understand what was going on there. We're not there. And as a result, I think both entropy, the arrow of time, a lot of the other questions that the physicists are stuck on, so badly stuck on, are things that we're going to remain stuck on until we make that next huge leap forward in physics, until the next Einstein comes along, or some combination of Einsteins come along that give us that next insight. We just don't have it today.
I think that's fair. I mean, to reinterpret your question a little bit, what is fundamental in the physical world? And I'll just footnote that quickly. Fundamental doesn't mean more important. I mean, the aspects of time that we experience directly are in no sense degraded by understanding it at a fundamental level. So what is fundamental? And I think one of the ideas in play today is that time is not among those things. And I'll just leave it at that. We can talk later if you want.
Could I, okay.
Yes. Does anyone know whether other animals experience time, or is it just a human characteristic? And the reason I ask is, many years ago, I heard someone told me that a dog, if you're gone 5 minutes or you're gone a week, it doesn't know the difference when you return. They have no concept of time. I always wondered if that was true or not.
Well, I can speak of from a biologist's perspective. I mean, animals do have a sense of time, but it's the kind of time that you guys were talking about. It's cyclical time. I mean, certainly is the change of the seasons, the change of the year. I mean, animals definitely have a perception of that. I mean, it's not like that squirrels are running around hiding nuts in in June. So certainly that there's that aspect of it, as well as a daily circadian rhythm as well, and things. So that aspect of time is pretty ingrained in lots of different animals. If it's like speaking about my dog, which I happen to, it's not my dog, it's my wife's dog, which I hate.
The dog or the wife?
The dog. But it certainly, I think, that knows the difference of whether you've been gone for a week or a day or 2 months.
It bites you that much harder.
Yeah.
Okay. Seems there's another.
Who are you?
Oh, my name's Tom Creasy, just a general student.
Yeah, I've seen you here.
Whatever's out here. Anyway, it seems to me there's a fundamental question. There's an assumption here that there had to be a beginning, but why does there have to be a beginning? Why can't it be eternal?
But let me just parse that question a little bit. What's the alternative to there being a beginning?
An eternal now.
But how does that help you? You still have a lot of these deep questions about why the universe exists, why it has the certain properties it does. Those questions you push back an infinitely long time, which to a cosmologist is nothing.
Well, maybe those questions exist because you are presupposing there was a beginning. There'd be a whole new way of looking at things.
Physicists, who are people? Sometimes are playing with both ideas, and the trouble you get into is that both lead you to various paradoxes and various conundrums. And so it's picture poison. Our own observable universe is observed to have had a beginning 13.7 billion years ago, plus or minus 0.1, whatever it is today. So we do know that everything we see, everything we can see, had some kind of beginning. The question is whether the broader reality of which we are a part had a beginning or not. And like I said, you can just, both are going to lead you into a conceptual corner. Both are, questions of entropy come up in both. Questions of why there's something rather than nothing come up in both. So,
and whether time is unique to our universe, whether our universe is unique. There are theories out there of multiverses, that is, enormous numbers of universes, perhaps being created continuously every time there's a decision point in the universe, like the Yogi Bear, every time you come to a fork in the road, pick it up. Lots and lots of forks in the universe, in the flow of time, and the universe may split into multiverses. For example, if that happens, are the laws in that universe the same as they are here? And in particular, does time behave the same way there as it does here? Almost certainly dependent to be able to answer those kinds of questions on the next great step in physics, to be able to move forward with it. But to go right back to the very beginning of your question, our observable universe almost unquestionably had a beginning. We see, in particular, the microwave background radiation that is beautifully and uniquely predicted by that kind of universe. We see details in it today, extraordinary details from satellites that observe it today in phenomenal detail that really lead us to no other conclusion. That's just the way it is. That's just the way it was.
Dave, I wanted to just sort of
Introduce yourself.
I'm David Kirkpatrick. I'm a journalist, write about technology. I'm pretty involved with this place here. And I just wanted to throw a little bit of a philosophy spin on it, maybe, if I could. Since this whole institution is very much about sort of matters psychological are very much imbued with our discussions here, and it hasn't come up too much so far, except through the constant reference to anthropomorphizing this and that. So what I was wondering is since time, as it's been discussed, seems to be very much really just a human concept. It isn't really anything other than that. It sounds like, more or less, if I summarize a number of comments, which may be wrong, but even if leaving that as a sort of a postulate, my question is, what will the human species do with what it is learning about these sort of principles of physics, these absolutes that we're starting to identify, given, as Olga mentioned and has come up, our impulse toward immortality. And I just wanted to postulate something, and I would invite speculation from the rest of you. One relating to something I've been thinking about is that I just found interesting, given some of these things that have come up here regarding, the relative perception, how time is affected by our speed, the relationship to other phenomena, and so much of the way that we perceive time is related to the rotation of the Earth and the revolution of the Earth around the sun. And then I think about something that's starting to come up quite a bit in science is the question of geoengineering. And the reason I think it's relevant is that, there is really the imminent prospect, the likelihood that we will start altering the Earth's atmosphere in quite dramatic ways. We have to because of global warming, in my opinion. But then you really take that further and you say, well, say we really get into nuclear power and we don't really need the sun, right? What if, right? What if we just, maybe we would decide to slow down the rotation of the Earth and or the revolution of the Earth around the sun. I'm just throwing that out as something that I think is a conceivable eventuality over the course of human evolution, given that we are learning more. And I just would invite others to speculate along those lines.
Well, why stop there? Why not actually detach the Earth from the sun and use the Earth as a spaceship?
That's
if you have
exactly
enough,
what I mean.
Yeah, if you have enough energy, take off across the galaxy and seed planets right across the galaxy. Actually, that's one of the best arguments that we're alone in the galaxy. Because if you could move it close to the speed of light, it would only take you 100,000 years to cross our galaxy. You would either terraform or mine or seed every useful planet in the galaxy. Nobody's put a shovel into the ground on Mars or the moon or what have you. It strongly suggests that we are alone. But that's a different point.
Because if we really do continue with our pace of technological evolution, we probably will get to the point where we can do that if we want to.
Absolutely.
Right, and so any other living species in the universe would probably have gotten to that point if they'd advanced as far as we have.
Well, in the galaxy, there's a difference. Travel between galaxies is much, much harder. But I'm curious, as a physicist, do you think that experience. Wait, just quickly, one last thing. As a physicist, do you imagine that mankind's ability to get to that point is thousands of years away, hundreds of years away, tens of years away? Well, all you can do is extrapolate from the past. There's no way of knowing what sort of technological breakthroughs we'll make next year or 100 years from now. But an example I love to use is the most advanced method of transportation available that we had in, say, 1492 was the sailing ship, one using sails, with which Columbus and his rowdy band managed to get across the Atlantic. 500 years later, a little bit more than 500 years later, it is the space station and various space transportation devices that we have today, which move about, maybe 10,000 times faster. So we've gained 4 orders of magnitude in 5 centuries. If we just gain another factor of 10, 1 order of magnitude per century, then you have to ask the question, how long then does it take us to get up to 99 or 99.99% the speed of light? And the answer is of order 1,000 years. So in 1,000 years, we should be capable, I think, of colonizing the entire galaxy. And I sincerely hope that we don't mess it up the way our forefathers
That presumes that we survive that long. Thank you.
Can I actually just pick up on the very first remark, the question you made, which was what will humanity or what will we, people in general, do with the knowledge that physics brings? I think, first of all, a physicist is probably the wrong person to ask that. An artist or a sociologist is.
Olga came closer to some of these thoughts.
I agree. But I think historically we do have some interesting precedents for major advances in our worldview that played out in completely unexpected cultural ways. Take the Copernican Revolution. Who would have thought that just relocating, switching the places of the sun and the earth, which at the time was just a mathematical contrivance, would ripple out into society and lead to the Enlightenment and all the developments that came from that. So I think it's unpredictable, and it's everyone in the room who will actually go home with these ideas and be part of that whole shift.
Hi, I'm Karen Rood. Can you help me understand what you mean by time as an emergent property? Is it apart from people? Or is it a human thing you're talking about? Is it mathematical? I mean, is it something aliens could perceive? I mean, help me with that.
Well, there's different ways that the idea of emergence could be understood, and whether it's something that we construct in our daily lives could be considered an emergent idea of time. But in the sense I was talking about was kind of a more technical sense, that if you begin to go down to the levels that Mike was talking about of 10 to the minus 44 seconds, these incredibly short time spans and the graininess of space and time that you would see down there, what's next? Where does that notion, those little grains of space and time, where do they come from? What do they represent at a deep level? And one of the ideas in play today is that they come from kind of a deep, even deeper level of reality, much as a familiar table might come from the atoms within it. That doesn't mean the table is not real, it's just that you can also think of it as being composed of atoms, the atoms in terms of particles, particles in terms of whatever particles are made out of, if anything. So at that deep, deep, deep level, you would have something that's timeless, that's spaceless, from which time would then be derived, from which then atoms would be derived, tables, buildings, people, planets, galaxies, and all the way up. So I'm speaking more in a kind of technical, scientific physics sense of emergence at that.
What's deeper?
Good question. No, but really, that's the cutting edge of science right now.
All right.
Well, there's so many questions that I'm in a quandary as to which to ask. But I think the main one is one that's probably shared by all of us here who don't actually work at your level. And it has to do in some way, I could say very simply, with the translation. How do you translate? Surely, you know, the phrase came up earlier about simultaneity being wrong and meaningless. Now, that can't be both wrong and meaningless. It's impossible. And that's, I think that represents a quandary. In other words, we have something in mind. And if it doesn't correspond in some way to what you're dealing with, there should be some connecting principle, and we all look for that principle. What do we make in, as we all admit that we're talking a language that is incompatible with what we're talking about. I think you more or less said, we can't help but say, you know, we talk about the universe having a beginning, for example, but then we also say that time is an illusion. Time is not fundamental, but it has a vector. The universe moves somewhere. You know, what is novelty? How do you translate? I think all people who, the average person like myself, is looking for something for a physicist to say, or a mathematician to say, we use a different language, something like that. And it only corresponds metaphorically to the language that you use, or that we use when we're going to our laboratory. And it's a metaphor. And we can give you the terms of correspondence. But I think it is very frustrating to be told that your universe doesn't really exist.
Why would that be frustrating?
Well, it's frustrating because we're stuck with it.
I'm
That's a simple answer.
No,
I'm stuck with it. And you're stuck with it.
I agree.
And we look to see what is the easiest, you know, the easiest out, cop out, which I would have, and I know it's wrong, but the easiest cop out is, look, that this is the only thing that, like the terms, the concepts, the old categories, including causality, which people seem to still believe in somehow. At least with your brother. And,
that's the level.
The causality, objects, you know, time and space, you know, that we like to think that these are real, but that there's something else involved in measurement. We've become terribly sophisticated in measurement. And measurement has, in a sense, extended or distorted the meaning of the concepts that we started out with. But we keep using, the technologists and the scientists keep using the same word. And it flummoxes us because it isn't exactly, they're using a word that comes from some problems in measurement, for example, but it isn't the same thing that we mean when we use that word. Now that's wrong, I'm sure that's wrong. But that's the cop-out, the easiest cop-out. Yes, yeah, I understand what you're talking. You followed this into a place where you've been, where the term is useful to you in a different sense than we use it, and you come up with these strange comments and so on, but that's science, that's progress. We can now do what we can examine more. Now, I know it's wrong. I know it's wrong because people fly, well, no, I was thinking about the example of flying into space and coming back. I would think that a person figures, well, I could still hold on to my old categories. Francis, you're a Kantian, I can tell. You always come up with them. I'm so glad there's one. I can still come up with my old categories and give an explanation, physiological explanation, of why they're young, why they're just a few minutes old, and while the sibling is 40 years old. Something's happened to their physiological. I mean, that's nonsense. I was going to use another word to say that. But this is what we strain for, I think, is some term of connection. Our reality is a reality. I mean, the alternative would be to say that we're, butterflies, dreamers. We have a reality, the one that we live with, the one that we paint, the one that we dream about. The significance of time. Some of it is arbitrary, measurements of time, and they're cultural and so on. But that is a reality. That's part of reality. Time may be granular, but the Bretsonian flow of time, or curve, that's also a reality that we have. It's there, it's a feature of the universe that we have it. They have to connect them some way or other and not simply say, well, it's just, we found out it's wrong, but also that it's meaningless.
Let me try to...
One further, I'm sorry. It occurred to me a minute ago that somebody might say, because I'm trying to work this out, what it means. You have this reality, we have this reality, but it's like an optical illusion. We now can tell you how things are and why you're fooled. I mean, that's a kind of way of thinking that one might have. But in ordinary optical illusions, you can provide the connecting terms for what was perceived, for example, what was there, what was misperceived, and why it was misperceived, and even what the function was of that which makes us misperceive.
I can understand your frustration. I really can.
Psychoanalytic.
Let me just make these are a lot of deep issues, and yeah, Kant is one of my favorites. I mean, I have to confess. The reality that we have, that we seem to be living in, has multiple levels. There's multiple explanatory levels. So the water in this cup is wet. I mean, who would deny it? If I poured it on you, you certainly wouldn't deny it. But wetness doesn't exist at the level of atoms. That's a concept that emerges from atoms or molecules of water acting collectively. Color, any of these basic properties that we have in our understanding of the natural world emerge. And that's what we want. That's what it means to explain things, is to derive those properties from something that lacks them. Otherwise, what kind of explanation do you have? If wetness were present in the water molecule, then you haven't explained it. But I can explain wetness as that, I guess, has to do with surface tension or whatever. But I can give you an account of what it means to be wet from something that lacks wetness. But that is not to deny wetness. So it doesn't deny the existence of space and time, or life and death, or any of these properties that we directly experience vis-a-vis time, to say that time doesn't exist. I'm speaking at a different explanatory level here. I'm going down deeper than the atom. I'm trying to explain atoms. I'm trying to explain particles. I'm going down, down, down to a point where there are no atoms, there are no particles. I'm getting to a point where there isn't even a time or space. But that doesn't mean that time and space aren't real. The words time and space would apply at a different explanatory level. So then comes the question of connection. How do you connect those things? And some would argue, I have some sympathy with this, that the true laws of nature are those the connecting laws, the connective tissue that take you from the atom to the molecule to the wetness of the water, that take you from this timelessness and spacelessness to the space and time to the particles and so forth and so on. There's something deep and profound in how these levels of reality relate to one another and how reality's put together. And I think that gets a lot less attention than the world is made of atoms, says the physicist. Well, yes, says the physicist, the world is made of atoms, but there's a huge amount of theory that describes how do atoms then lead you to molecules, that then lead you to chemical reactions, that lead you to life, and so forth and so on. The standard model of particle physics, a lot of it concerns the relationship of explanatory levels. And I guess it's the fault of science writers and others that maybe we haven't got that across yet. But the connective tissue is important. And I apologize to you on the behalf of physicists and physics writers that we've yet to really convey that. But it's really an important part of what physics is. And it's to emphasize, it's not to deny that space and time are real phenomena. It's just to move to a different level to try to explain them. I don't know if that maybe touches on an answer to your question.
Just one point I wanted to add to that beautiful explanation, George, and that is there's no such thing as the perfect translation from one language to another. And the translation from mathematics to English is imperfect. And mathematics is the language which appears to describe the universe. And English doesn't do as good a job. So the failing is not the science writers, I don't think. I think the failure is in the fact that going from mathematics to English is very hard, sometimes imprecise, and can be very frustrating for a non-scientist. Ideas that seem completely loony, crazy, silly, become crystal clear when seen in the cold, hard, exquisite reality of mathematics.
You go to another question?
Yes, another question. My name is Winifred. Going back to what Peter said about using time to deny death, I'm reminded of that old philosophical argument that you can't have a last moment because you have a minute, and you have a half a minute, a quarter a minute, and so on ad infinitum. Yet Michael said that you can subdivide time infinitely that way. Now, why doesn't it work?
I'm sorry, why doesn't what?
Why doesn't it work? That philosophical idea of bingo, we have no death because we don't have we can't have a last moment. If we have a minute before it, a half a minute before it, a quarter of a minute.
No, but then you only have 10 to the minus 44 seconds before it, and that's it. And then the Grim Reaper comes along, and you're done. It's over. That's why. That's why.
But what is the reason that you can't subdivide time infinitely?
Can't tell you that. We don't know the answer to that. All we know is that that's the observed reality.
I have answered. There is actually different infinities, countable and incountable. For example, if you take the straight line, and just the part of straight line, anyone, even teacher in the school, say you there is indefinite number of points on this line, but it's still but it's incountable infinity. Countable is 1, 2, 3, 4, 5. So it's different infinities. I couldn't explain it better because I'm not in the mathematics field, but it's possible to explain.
To use Olga's example, there are only a countable number of events that have happened since the beginning of the universe. If each one of those events is separated from another event by 10 to the minus 44 seconds, and the universe is about 3 times 10 to the 17 seconds old, that means there have only been about 3 times 10 to the 51 countable events over the entire history of the universe. That's an enormous number. I mean, that's 3 with 51 zeros after it, but it's not infinity. Okay? There's a finite number of events that have happened so far in the universe. So far. What's an event?
Yeah.
Yes, it's also the big fish.
Excellent question.
I think the last should be the last one. Yeah, our last question of the day. Go ahead, Jim.
My name is Gibbs Williams. I'm a psychoanalyst. I want to free associate briefly for a couple of minutes. I think you will bear me out. You won't be disappointed. I'm here because, well, I took a few notes. I'm here out of a rather exquisite simultaneous occurrence where a good friend of mine who I roomed with at Columbia University, I was beginning class of 55, Frank Wilson, I had indicated to him in a recent email something, and he said, last night, you got to go to this group, which I can't pronounce. What is the pronunciation of this?
Don't worry about it.
Whatever the mythological origin is, it's marvelous. He said, you got to go meet Francis, and you're going to be in tune with this. Then I looked at the name of the conference on time, and that it was an integrative experience, and I did keep a lot of notes, by the way. This was really fascinating. And I think back to my early days at Columbia when I was scared to death to have to take an elective science course. I majored in philosophy. That was the only thing that made any sense to me, still does. And a few other things I would have added. I took a course with Lloyd Motz in astronomy, figuring, boy, that's going to be a winner. That'll be easy. Oh, my God. Math, physics, everything. It was impossible. But the first day, he said to our graduating class, which would be 59, he said, folks, I'm going to make a prediction. This is I think I took the course when I was a senior. In 59, he said, I'm going to make a prediction. In 10 years, you guys are going to applaud the fact that we are going to be on the moon. And it was exactly 10 years later, we were on the moon. And that was remarkable to a kid from Florida going to Columbia and feeling that we had a prediction we were going to be on the moon. Good timing. Getting back to Frank Wilson, good timing. The timing is extraordinary to me because of the following. I have a book coming out in about 5 weeks. It happens to be something which is not foreign to this group called Demystifying Meaningful Coincidences, Synchronicities, the Evolving Self, the Personal Unconscious, and the Creative Process. I feel like I have a numinous experience. This is a Jungian term. I'm not Jungian, I'm more or less Freudian. But all that you've talked about is central in this book. Simultaneity, causality. You know, Jung's big on acausality, which is really causality under a phony name of acausality. I come up with a concept of psychological causality. I have a different form of logic that instead of linear logic, you're dealing with messy feelings, which becomes what I call experiential logic. That's the kind of thing I explore in the book. I find this marvelous because from my vantage point, such puzzles can only be worked out or comprehended until, or unless and until, there's an integrative approach. And I appreciate the fact that there's an integrative approach. I use, for example, in my theory, my naturalistic theory of synchronicities, no mystical, magical stuff. It's all naturalistic. I use a sort of five-fold perspective of speculative philosophy, depth psychology, aspects of the esoteric occult, aspects of what I call grounded spirituality, and aspects of physics and science. However, Jung did the same with 5 other perspectives, and I suppose if you have still other perspectives, you would get multiple interpretations of synchronicities. But you can see why I feel numinous. This is a marvelous experience, and I'm very happy you all exist, and I'm glad I'm here.
Thank you very much.